Hello, today we are looking at speed time graphs. So last week we were doing about distance time graphs, and these are similar, but there are some important differences. And one of the things that you need to make sure you're able to do is tell the difference between the two. So we're going to look at what a speed time graph looks like, what it can tell us, especially what the gradient on this graph can tell us and how that links to acceleration, and also how we can work out the distance travelled from a speed time graph. So if we look at a speed time graph, very similar to a distance time graph, we have time along the bottom, but instead of having distance up the side, we have the speed. So this shows the movement of an object, let's say a car going on a journey, over 60 seconds. And on our y-axis, instead of showing how far it's gone, it shows the speed that it's going. So on a speed time graph, if the line is going up like this, that means it's accelerating, because between 0 and 5 seconds it's getting faster because the line's getting higher. The higher up the line, up the scale, then the faster it's going. So a line going upwards shows it's accelerating. If the line goes downwards like this one, it means it's decelerating, it's slowing down. If the line is straight like this, on a distance time graph, if you remember, that means the object wasn't moving, but in this case that's not true. If it's at a straight line like this, that means it's moving at a uniform speed, so it's going at a constant speed. Or if it's a straight line at 0, that means it's stationary, because if at 55 seconds it was going at 0 meters per second and at 60 seconds it was going at 0 meters per second, that means it's not moving at all. So you need to know what the difference is. If you remember a distance time graph, a straight line going up like this meant it was going at a constant speed. A straight line meant it wasn't moving. On a speed time graph, a straight line going up like this means it's accelerating, and a straight line means it is moving, but it's going at a constant or uniform speed unless the speed is 0. So we can work out the acceleration of an object from a speed time graph by calculating the gradient. So like I said earlier, if it goes up like this, then it's accelerating, and if it goes down, then it is decelerating. So if we have a look at an example, here's a speed time graph again. What is the acceleration of the object between points A and B? So here's A and here's B. We actually do it exactly the same way as we did it for the distance time graph. We have to work out the gradient for this one. If you remember from last lesson, acceleration is the change in speed divided by time. So the change in speed, it started at 5 meters per second and it ended up at 25 meters per second. So that means the speed has increased by 25, take away 5. So that's increased by 20 meters per second. So that's our increase in speed. To work out the time is how long this took. So B is at 6 seconds, A is at 2 seconds. So the difference between 6 and 2 is 4 seconds. So putting that into the equation, acceleration equals speed divided by time. It's going to be 20 divided by 4. So our answer will be 5. And remember, our unit for acceleration is meters per second squared. So that's how we can work out the acceleration from a speed time graph. There's one more thing we can work out as well, which is actually looking at the area underneath the graph. And this is a bit more tricky. The area under the graph, so if you imagine this is a shape, so this area of this shape will tell us the distance that the object has travelled. And actually, if you've got a graph, you can actually measure that area to work that out. The easiest way to do it is to divide it into shapes, into rectangles and triangles. So this shape here, it'd be quite difficult to work out the area, but if we divide it into a triangle here, and then a rectangle, and we add the area of those 3 shapes together, then that would help us work out the area under the graph. So to do this, you have to get your maths brains on, because we need to use a bit of maths. To work out the area of a triangle, it's half times the base times the height. So if we look at triangle A, the base of this triangle is 4, the height is 7, goes from 0 to 7, so it's going to be half times 4 times 7. That will give us an answer of 14. Area B is a rectangle. To work out the area of a rectangle, hopefully you know it's the base times the height. So the base of this one is 3, The height is 7, so 3 times 7 is 21. That's the area of this shape. And then for our last triangle, half base times height. The base is 2 on this one. The height again is 7, so it's half times 2 times 7, and that gives us an answer of 7. So if we add those three numbers up, this was 14, this was 21, and this was 7, all adds up together to 42. So that will tell us that in this journey, this object travelled 42 meters. There we go. Simple. What I'd like you to do for today's lesson is have a go at the worksheet which I've put on Google Drive. It's called Car Speeds. There's a few questions I'd like you to answer, and you need to submit this one so I can mark it, please. I've put it as a PDF and as a Word document. It's up to you how you do it. You can do it on a computer and submit it. You can write it, send me a photo or whatever. Originally you would have had to draw a speed time graph. I know probably you don't have any graph paper, or not many of you probably will. So because I'm really kind, I've drawn this speed time graph of this car journey on here. So all you need to do is answer the questions. For question 2, describe the motion of the car at each stage of the graph. I want you to say what's happening between this point here and this point here, what's happening in this section, and then what's happening in this section here. The other ones you should be able to answer using this graph. So do that please, submit it on Google Classroom, and that is it. Any questions, please ask me. Thank you.